In problem number 5, we are asked to find the greatest common factor of 40, 20, and 4. Now, the greatest common factor is the biggest number that divides into 40, into 20, and into 4. So the way we're going to do this is we are going to take the 40 and we're going to write it in terms of its prime. So first of all, 2 is a prime. 2 will go into 40 20 times. But we can write that 20 as 2 times 10. 2 times 2, and we can write the 10 as 2 times 5. So 40 can be written as 2 cubed times 5. Now let's do the same with the 20. The 20 can be written as 2 times 10. This is going to be 2 times, and 10 is 2 times 5. So what we're going to get here is 2 squared times 5. And then with the 4, we can write this as 2 times 2, or 2 squared. Now, the greatest common factor is the factor. Now, here's the factors: 2 cubed and 5, 2 squared and 5, 2 squared. So the greatest common factor in this case is going to be the 2 squared. It's this number here, 4, that divides into the 4 divides into the 4, it divides into the 20, and it divides into the 40. And it's the greatest common factor because the 2 squared is here, the 2 squared is here, so it's common to both of these. And there's a 2 squared in here, right? This is 2 cubed, but there's at least a 2 squared in here, 2 squared times 2. So the biggest factor that appears here, here, and here is the 2 squared. The 5 is not going to work because it's common to these two, but not to this one. So we're going to conclude now that the greatest common factor here is 2 squared, or 4. So let's take a look at the common factor, greatest common factor of these 3 quantities. And let's start here with the 70. Now the 70 we can write as 2 times 35. This will be 2 times 5 times 7. So what we have here is 2 times 5 times 7. Let's look at the 30. The 30 we can write as 2 times 15, but we could break down into 2 times 3 times 5. And then that 60 we can write as 2 times 30. That's going to be 2 times 15. We can write that as 2 times 2 times 3 times 5, or 2 squared times 3 times 5. So when we get the prime factorizations for the 70, we get 2 times 5 times 7. For the 30, 2 times 3 times 5. And for the 60, 2 squared times 3 times. Now what we're looking for in the greatest common factor is the number that appears in each one of these factored forms, the number that appears in each one to the smallest power, because that's going to be common to each. So here's a 2 to the first, a 2 to the first, 2 to the second. So there's at least a 2 to the first in each one. So our greatest common factor of these 3 numbers is going to be 2 times, now the 3 doesn't work because the 3 is not up here. It's here and here, but not here. So the 3 is not common. And the 5 is not, well, the 5 is common, isn't it? The 5, we've got 5 here, here, and here. So we're going to have 2 times 5. But now this 7 appears here, but not here or not here. So the greatest common factor is going to be 2 times 5, which is 10. You may be able just to see this, that what's the biggest number that's going to go into all of these? It's 10. Now that's for the numerical parts. Let's get the greatest common factor for the x cubed, x to the 4th, and x to the 5th. So clearly the x is common to each one of these. And we've got 3 of them here, 4 of them here, and 5 of them here. So the greatest that's common to each one of these is going to be the x cubed. Let's just be sure we've got that. Here's the x cubed. The x to the 4th we can write as x times x cubed. And the x to the 5th we can write as x squared times x cubed. So what you can see here is that the x cubed is in the first one, it's in the second one, it's in the third one. So the factor that's the greatest factor that is common to both, or all three, is the x cubed, and the x cubed. So that greatest common factor is going to be the x cubed. So the greatest common factor here is x cubed. So all in all, the greatest common factor of these three quantities is 10x cubed. And we're saying that this right here is the biggest quantity that goes into each one of these. Now in problem number 19, we're looking for the greatest common factor of this term, and this term. Now let's look first of all at the 30, the 45, and the 90. Now, do you see that 15 will go into here, into the 30, right? 30 is 15 times 2. 15 times 3 is 45, and 45 goes into 90 twice, so we're going to have 15 to go in here 3 times, so it'll go in here 6 times. So the greatest common factor here of those numbers is going to be 15. And the greatest common factor for the variable parts, now this is between the r to the 4th, r to the 6th, and r to the 9th. We're going to pick out that factor. R appears in each one, and the biggest it appears in each one is the r to the 4th. Now even though over here it's to the 5th, it's to the 6th, and to the 9th, the biggest that's in each one is a 4, right? You can't be a 6 because there's not 6 of them over here. And then the same idea with the q's is that you've got 3 q's here, 5 here, and 4 here. So the quantity, the variable with the smallest exponent is the cubed, so we're going to write q to the 3rd. So 15 r to the 4th, q to the 3rd is the biggest quantity that divides into each one of these originals. Now in problem number 29, we're looking for this. We've got negative 20 z to the 8th, and it's partially factored already. Negative 4 z to the 6th. So what we're asked for is, what do we put here such that when we multiply this and this, we get this number here? Well, we're multiplying, so all we have to do is do a quick division in our heads, and we can probably get this. So what are we going to have here? Negative 4 times what is negative 20? We'll just do a division. Negative 4 into negative 20 is going to be positive 5, right? Negative 4 times 5 is negative 20. And then for the z, we want 8 z's. We've already got 6, so we need 2 more, right? We have 6. You can see it here. We have 6 z's, and we want to get up to 8. We know when we multiply, we add the exponent. So from 6 up to 8, we need 2 more.